Welcome back. In this video, we'll be actually looking into a couple of very interesting topics. One is the remote VPN with Anyconnect client, right? And the other one is the deep packet inspection of the ASA, right? So let's start with the remote VPN with Anyconnect, all right? So the topology is pretty simple, what I've shown on the screen, right? So we basically have a very simple ASA. We have a router R1 on the inside and R2 on the outside. I think we have followed the similar topology in all our previous exercises as well, right? The only change here is that we are basically going to have one more PC which is going to be present on the inside, right? And on the outside we are going to simulate the internet, and we are going to have a remote device as well, right? So that is the topology. Now what we are trying to do here is we are trying to establish a VPN, a remote VPN, right, from this remote box or remote device, right, towards the ASA. So there will be a VPN over here, and we are going to use Anyconnect client, right, for doing this. So in the earlier videos, I think we have already covered something called as a clientless VPN, right? So clientless VPN helped us, access HTTP, FTP, and CIFS resources, right? But when it came to some native services like Telnet, we had to do port forwarding, right? That was the SSL clientless VPN. So now we are trying to do Anyconnect. We're going to try another setup where we're going to use Anyconnect client, and we are going to see how we can beat the challenges which we had with clientless VPN. Okay. Also, the other important difference is clientless VPN was only SSL, but in case of Anyconnect VPNs, we're going to have both IKE1 and IKV2 as well, right? So how does this actually work? So here the Anyconnect tin client, right, which you probably would have already seen before on your company laptops and so on, is generally stored in the flash, right, flash of the ASA, right? So when the first time the VPN is being set up from the remote device, the remote device will be flashed with a page where it can download this ASA client from the flash. So that will be the first step. There is also an XML file, right, which is basically the profile file that needs to be created on the ASA, which will later be downloaded on the remote device as well. Now till now, whatever we have done on ASA, we have done it using the CLI, didn't we? But to create this profile XML file, it is very difficult to do it on the CLI. So that is the reason we are going to start using ASDM, basically the management center for my ASA, right? And that is this particular management PC, right? So from this management PC, we will be able to connect to the ASA through the ASDM, right? So yeah, so that's how it's going to work. We'll look into the configuration and the whole setup as we go about it. All right. So this was the topology. Now I already have the topology created here. So this was the logical topology, and this is the physical one. I have the ASA here, R1, R2. The PC1 and PC2 are nothing but so the PC1 is basically my machine on my host machine, right? And so this is going to be the network, right, for my inside network, and the PC2 is basically a Windows machine which I already have over here, right? So these are going to be my two machines. Okay. Now I'm going to establish this. So here, as you see, it was a little tricky to build this because I need to have both my R1 and my PC on the same network, or basically and also the inside interface of the ASA to be in the same network, right? And that's why I had to go and create what you call as a VLAN. So I created a switch, connected all these ports, and put all of them on the same VLAN. So I haven't done the configuration sets, which means we can start looking into it now, right? So let's do this. So let's start by configuring the switch. Let's put the configurations on my file over here, and this should be good. So let's start by configuring the switch, right? So the switch is basically nothing but I'm just going to put all the interfaces, all the three interfaces, 0/0, 0/1, and 0/2, all the interfaces in the same VLAN, right? So that they have the same broadcast domain, right? The next is, let's go and do the configuration of my R1, right? And let's see if this is R1 is able to connect to my PC1, right? So that's important. So let's do that. The R1 is going to be again pretty simple, right? So there you go. So I'm just putting the interface, address is 10.11.11.1, right? So this interface is 10.11.11.1. A default route is going to be towards ASA 10.11.11.10, and I'm also going to put the telnet configurations, right? The next configuration which we will have to do is the ASA, right? Or let's just put these two and see if we have connectivity to the local host. So let's put this on the switch, right? So let's did that. Whereas let's do it on R1, right? So on R1 it's going to be this one. There you go. So now we should be able to actually ping from R1 to my PC1, right? So where is my PC1? I'll have to open this terminal, right? Let's open a new one, so that, yeah, so there you go. So let's see if I can ping to my R1, which is 10.11.11.1. There you go, it is able to ping, right? Which is pretty good. Let's also see if we can ping my PC from here, which is 10.11.11.90 if I'm not wrong, right? You are able to ping. So we have connectivity over here, right? Now let's do the configuration on my ASA. Right, so on the ASA, let's do the configuration on ASA. Let's go to the file here. Okay, so on ASA, what do we do on ASA? Let's do the inside interface to start with, sorry, the outside. So this is the outside interface, gigabit 0/0. I'm going to put the address as 192.1.20.10, right? So you have seen this. This is the interface I'm talking about, 192.1.20.10, which is the outside interface. Let's do the inside as well. You have done all of these configurations earlier as well, so it's not something new. The inside is 10.11.11.10. Okay, and let me also put a default route towards R2, which is 192.120.2. Okay, now there is slight change, or basically we have to add few more commands, because what we are trying to do is we are trying to set up the ASDM, right? So we need to have the ASDM connectivity to ASA. So ASDM works on HTTP, so we need to first go and enable your HTTP server and also enable it on the inside interface. So this will do that. So you do HTTP server enable, and I also tell that HTTP allow it from the inside interface, right? So that does it. Okay, great. Next, what do we do next? So next is we need to, because we are trying to access the ASA over HTTP, we need to have some login credentials, shouldn't we? So we're going to put that. So we're going to put a username Cisco, password as Cisco, privilege level of 15, and AAA authentication, I'm going to call it as local, right? So I think that's all done. So this is the basic configuration which would go under my ASA. So let's do that. Let's put this on ASA. Let me clear the screen. There you go. So that's done, right? Which means now my ASDM, which is on this, should be able to access this. So how do you access the ASDM? So to start with, I would say you can go down to your browser, which is on my local machine, right? Host machine basically. So you can go down to the IP address 10.11.11.10, right? So when you go here, so you get this page. Right now you can install the ASDM launcher, because this is quick. Now I have already installed it, I've already downloaded and installed it, so I need not install it again, right? So I already have it here. If I believe I should already have it here, let me open it. Yeah, there you go. So I need to plug in my IP address, and I'm going to put in the password as well. Put in OK, continue. That's the launcher, and I should have my, yeah, there you go, that's it. Okay, looks good. So this is my device 10.11.11.10, and you can see my ASDM is all good, all set up here, right? So this is the ASDM wherein you have lot of ways to configure your ASA, but on a GUI, using a GUI and not using CLI, right? So that's ASDM for you. Great. So what have we done? We have configured all of this. We have configured the ASA. Let's go and do the configuration of my R2 now. R2 is going to be pretty simple, right? Similar to how we did R1. So just put a IP address 20.2 on this interface. Let's put 100.2 on the outside interface, right? And the telnet configuration. So that goes for R2. Let's put this on R2. There you go. So that's done. Now what do we do next? The PC. The PC is already here, right? So this is the PC, and what have I done? I've already configured the IP address on this, which is 192.1.100.98. It is being put in the same network as this one, right? Which means now R2 should be able to ping 192.1.100. If I'm not wrong, it is 98, right? 98, yeah. So R2 should be able to ping that. Yeah, so R2 is able to ping the PC, and let's see if I really don't want the browser anymore, so let me close this, right? So let's see from here, from the PC I'm able to ping R2 192.1.100.2, right? So the ping is working. Great. Now let's see if we are able to ping 192.1.20.10, right? So what is 20.10? It is my ASA. Not able to ping, right? The reason being, if you look at the topology, so I'm trying to ping from here to here, right? And there is no route here, so I need to put a route here, which means let's do that. So let's put the route. How do you put a route on a Windows machine? So you say route, you say route address 192.1.20.0, right? 255.255.255.0. Sorry, I think I need to have a mask here, my bad. And I'm gonna put the next stop, which is 192.1.100.2, right? So the next stop is R2. So now once we have put this route, we will be able to ping the ASA. There you go, it's able to ping the ASA, right? Which is perfect. Now, so we have all the connectivity and everything set up, right? So now what do we do? Okay, so now we have to use the ASDM which is there on my PC1 to configure the ASA so that it is ready to connect, or so that it is so that the Anyconnect VPN is set up, right? So from now on we are basically going to use the ASDM which is here, right? So the ASDM is here. Great. So let's start with this. To start with, you can see that this is basically the device list, right? You can see the devices which are there. If you have multiple devices, it will be visible here, but in our case we are basically going to do the Anyconnect VPN part. So let's go to wizards to start with. Let's go to VPN wizards, click on Anyconnect VPN wizard. Okay, click next. Now let's give a name for our connection profile. So what do we give? Let's say IKV2 IKV2 VPN dash Anyconnect, right? Let's call this IKV2 VPN Anyconnect, and the interface is going to be out. So we go and put the next. To start with, like I said, Anyconnect VPN allows you to have two either of the you can use either of the protocols. You can either use SSL or you can use IPsec. But to begin with, right, initially you need both the protocols, right? You need SSL, right? So even though your exam says, or someone tells you to set up a VPN with IPsec, I would say keep both of these enabled initially, you can come and disable them later, because you want SSL to set up the initial, to download the Anyconnect, to download the profile and all of that. You still want SSL. So let's keep this, right? Now the device certificate. Now this is important. Let's go and create this. Okay. So we create certificates. Now we don't have a CS server, so we'll be creating a trust point here, right? So let's create a trust point. What do we call this trust point? Let's call this trust point as IKE v2 underscore trust point. Okay, TP. Add a new identity certificate, right? So do we have any certificates? No. So let's create new. So when you create new, yeah, so it's going to be RSA, right? And let's go and enter a key pair name. So it's going to be like VPN probably dash KP. Okay, good. Let's make it general purpose 1024. All of this is good. Let's create. Okay, and once we are back on this, what do we do next? Let's go and enable this. Let's enable this because it's self-signed certificate, right? And we are going to add the certificate which we just now created, right? Enrollment succeeded. Great. So we have added the certificate here. Next, what do we do next? So we go and click OK, right? Once that is done, it has appeared here. You go and click next. Now this is interesting. So here what we do is so like I said, initially when when the client, which is here, when the client is trying to connect to the VPN, right, it might not have the Anyconnect thin client, right? This device might not have the client, so we should provide it with a link so that it can download the client, right? So that is what we are basically going to do now. So since it's going to be a Windows machine, so I already have it. So what we do is we have to upload a Anyconnect image, right? So that particular end device can download it and start using it, right? So let's upload it. So when you upload it, I'm not sure if we already have it. Let's see if I already have it. Browse flash. Oh, there's something already there. So I've already uploaded it before, so I need not upload it again. So there is one here, right? So that's the one. So you can upload as well, right? You can upload it again. So this is the old profile which I had created, so it's still here in the flash. The new one which I'll be creating will be slightly different, right? It will get created automatically. You need not create this. Now anyway, we will select this image because that's important, right? Let's select this, right? So that's your Anyconnect package. So this will be given to the device. I will show this how this works, right? So I'm just selecting the Anyconnect client image over there. So I've uploaded that. Next, let's go to the next. Now it is asking me to create users, right? So I'm not going to create any new users. I already have one which I've created. I'm going to use them. If you want, you can create new as well. I'm using local authentication here, right? Let's click next here. Nothing to change. Now the pool. So when the tunnel is being set up, the thin client which is there, or the Anyconnect client on the device, right, will get an IP address, and we have to define the pool of the addresses it can use. So let's create a new pool, right? So let's create this pool called VPN probably dash pool. Let's call this VPN pool, right? What is the starting address? Let's start with 192.168.101.1, and let's end with 192.168.101.254, right? And the mask is going to be 255.255.0. Great. So put a OK here, and we're going to click next. DNS service is not actually needed, I mean, in our case, but we still need it to complete the configuration. So let's put just R1 as my DNS server for now. It won't be used anyway, right? Great. Exempt VPN traffic from network address translation, right? We are not doing any NAT. If we were doing NAT, then we had to check this. I'm going to go next. Allow web launch. So when the web launch happens, right, when the VPN connection is being set up, you get a web page which gives you the link to the package over here which I have uploaded earlier so that they can download it. Right? Great. So let's go and finish this, right? And which is done. So let's finish this. Right? So that's done. So those were the initial steps which you have to do. Now there are a couple of other steps which we need to make this work, right? So what are those steps? So we come down to the profiles, and on the profile you can see here, you click and edit, and on the basic you go and click the group policy, right? So this is the group policy, right, which we have. If you click on this edit, why we need to do this is because the next two steps which I'm going to be done, it should be done, else we will not be able to RDP and then do the VPN. Only local initiating VPN will be allowed, right? So in many of your cases you guys might be running RDP sessions on your labs, and if you want to initiate a VPN from a RDP session, it won't allow if you don't these two steps, right? So that is why we do this. Great. So we are here. What do? You go to advanced, you go to split tunneling, right, and you create a policy where you're saying basically you need to allow tunnels, right, from network which are listed below, right? And what's the network list? It's basically something which you have to create. So let's create a network list, right? Is there a add CL? Probably let's call it as split tunnel. Right, now you can add a AC to this. Permit from which network? I want it from 10, 11, 11. Okay, so this is I could use this inside network, right, basically. So I want the VPN tunneling only towards my inside of the network, right? So that's why I need to select this. So I'm going to put an OK here, right? Let's select the OK again, right? So that's good. Let's put an OK. This is going to be an OK, another OK. I'm going to apply this, right? So we did that. And what do? The next step is again we go to Anyconnect profile, click on edit. So you need to do the change here as well for the same reason, right? You need to, so you can see here VPN establishment, it allows only local users, but what if you have like a RDP session? So in that case you have to allow this, right? So I'm going to allow this, I'm going to apply this, right? Let's see if the changes happened. Please exit and restart to refresh. I guess so. Yeah, so let's see if the changes happen. Yes, the changes happen, right? Great. So that's good. So these were all the steps which you had to do, right? And you have applied as well. Great. So now let's go down to my PC, right? Which is my PC2, right? So this PC2, and this is my PC2. So let's go down to this PC. Right, so this is my PC. Looks good. So what do we do to start with? You go to the browser. Remember, we have it set up a VPN, Anyconnect VPN session towards the ASA, right? So we go down to the browser, and it's a bit slow, my bad. Yeah, so this is my browser. So on this browser, let me put the IP address of my ASA, right? There you go. So this is my ASA. Right, so this is safe. Let's proceed to this, and there you go. So it is asking me for my username, password, which I have already set up, Cisco and Cisco. Yeah, so this is what I meant, right? So it is trying to set up, and it also gives you the link to the Anyconnect VPN, which when you click you can download it and you can install it. Now in my case I've already installed this Anyconnect VPN client, so I can directly use that, right? So it's going to be somewhere here. There you go, right? So I already have it here, right? So I need not install this again, right? Otherwise you had to, right? So in my case it's already there. I'm going to use this directly. So now what do we do here? From here I just go and put in my IP address, which is 192.1.20.10, right? I'm going to connect it. So what is happening right now? The first time, right, so I have to log in using the password. The first time the profile gets downloaded, right, because you want the profile, and for that the SSL is going to be used, right? I'm going to say connect anyway. Now those errors were coming because my certificate is self-signed, right? So the downloading of the profile is basically happening, right? For the VPN is IPsec and it's not SSL, right? So that you can know from here. Yeah, so if you see here, right? So if you see the server list here, so if you see the server list, the primary protocol is IPsec, right? So the first time SSL is going to be used to download the profile, but after the profile has been downloaded, we are basically going to have, right? So you can see here, the VPN has been set up, right? It has connected. So now if you see here, it's a bit slow. So if you see here, you can see that the protocol is TLS, right? The protocol is TLS because it is the first time. Now if I disconnect and try to connect it again, right, this protocol will change. So I can show you that. Let me show you that. Yeah, so now you can see the IPsec IKv2 protocol here, right? Earlier you had the SSL protocol being shown, but now since the primary protocol is IKv2, that is being displayed. So that's what I wanted to show you, right? Great. Now let's also talk about the deep packet inspection, right? Pretty interesting again. So deep packet inspection, where do we start, right? So we already know that the firewall inspects the TCP and UDP packets to create return entries, right? So if a telnet is going from inside to outside, then the return connection will also be allowed, right, inside the firewall, because there are return entries created on the firewall, right? So now let's take a protocol such like FTP, right? FTP works on the port 21, right? So let's say this is the client, so we have a client on the inside and we have a server on the outside, and we are doing a FTP connection. So FTP works on port 21, so the connection goes out, but and basically the authentication and login kind of messages are exchanged on this channel. But let's say now the FTP file exchange has to start, right? For that to happen, the server will generally create one more session on a different port. Generally it is port 20, right? and a port 20 message or port 20 channel has to be created through the firewall, but the firewall doesn't have written entry for port 20, right? Because there was only one channel which was initiated from inside, only that will be allowed by the firewall, but the device which is outside here would not be able to use that channel to exchange files. So we need to have one more channel which is starting from another port, which is port 20, right? Ideally firewall should drop it, right? But now this becomes interesting. So firewall has a capability to inspect, right? So it does the inspect logic is basically going to differ from different protocols, right? Firewall does an implicit inspection of TCP and UDP. It also does default inspection of protocols such as there are certain protocols which I can show you here. Let's do this. Show run. I think you probably would have seen when you do a show run of ASA, you can see some of the global protocols which it already inspects. This is all crypto part. This is all configuration coming from the earlier ones, earlier VPN setup which we did. Yeah, so I think you can see here. So these are the protocols which I'm talking about. So there are like default inspection being done on some of the protocols like FTP, SMTP, and so on, right? And because of this inspection, the firewall is actually able to read the messages, read the protocol messages, and the second channel which I earlier talked about from initiated from the port 20 is also allowed because of this, right? Because of this inspection, else FTP would have not worked, right? So this inspection logic changes from one protocol to different protocol, right? So you can read about it to get more information on that, right? Now what about the protocols which are not existing on this particular list? Like for example ICMP. Let's say I have a requirement where I want ICMP to be allowed or to be inspected, right? So we can do that. We can do that under a concept called as modular policy frameworks, right? MPF. So in modular policy frameworks, you can actually classify the traffic, and you can take action and then apply it, right? So let me show you how we do that. So like for example, before we do this, let's go and probably go to R2 and create a default route towards R1. I mean for this network. Sorry. Right, so we are basically creating a default route towards the 10 network because there is no default route on R2, right? I'm creating a default route. Right now if I go on R1 and if I do a telnet to 192.1.20.2, the telnet works, right? Which means there is connectivity towards R2, but will ping work? Ping to 192.1.20.2? No, the ping is not working. The reason is because, like I said, the inspection of the ICMP is not happening, right? So let's fix this. So how do we fix this? We go inside the policy map. Let me clear the screen a bit. So I do policy map global policy. So we go inside the global policy. Sorry, it's actually my bad. Let's actually go back. Global_policy, right? So we go into this and we basically call the default inspection class, right? Inspection_default, right? So we call this, and under that we basically say inspect ICMP, right? So we have done this. So now because we have added this, right, we will be able to see this. So if I do probably something like show run policy map, you can see that the ICMP has been added to the inspection logic, right? Which means now I will be able to do R1 I'm able to ping R2, and the ping is going through because the inspection is happening, right? Isn't that great? Yeah. So you might be a little confused as to what is this class map which I use. So the class map, the default class maps which I just now configured, right here, for example, over here. So I used policy map global policy. So this is the default policy which is there, right? And I also used the class map which is inspection default. Now these two are already there. I can already actually show you, right? So if I do something like show run class map, right? So this is the default class map which is already there, right? And what does it match? I just need to put a match and a question mark. Sorry. So if I go inside class class map inspection, let me actually pick this from here, inspection default, right? So if I do, let me clear the screen. So if I do match and a question mark, you can see these are the things it gets matched, right? So for ICMP there is already a logic to match, right? You can find it here, right? So that is what I wanted to cover under deep packet inspection, right? So what we covered, if I have to sum it up, right? So we earlier learned that TCP and UDP inspection is being done by the firewall, which is great, but there are cases where you would want firewall to inspect some of the protocols because they all don't behave the similar way, right? SMTP might have a different logic, whereas FTP might need certain other extra there would be certain things which has to be allowed for these protocols to work properly, and that's where the deep packet inspection of the firewall comes or kicks in. Now we also saw that we already have a default policy and a default class, right, which is able to inspect some of the popular protocols. But if, let's say, some of the protocols don't exist in that, like for example ICMP, you can add this particular protocol to the list of inspection, and in order to add it you use something called as a modular policy framework, right, where you need to first classify the traffic, and some of the classification of traffic is already being done here. Like for example, you can see this is the default inspection, default matching, where you can classify all these protocols by default. So for example ICMP was the one which I was very interested in, so the classification is already happening. So I just needed to create, I just needed to add this to the default inspection logic, and once I added that, I was able to do the ping from R1 to R2, and it succeeded. Basically the firewall was able to inspect the ICMP as well, right? So I would recommend you to read up on the packet inspection a little more to understand the various the global policies and the global and the default inspection class maps, to see what already exists and what not, so that you can think about writing more of these or adding more protocols to the inspection logic if and when needed, right? So thanks a lot for watching. Have a good day.